concept of time seems self-evident. It is something which is flowing, non-stop. Time is represented through change, such as the rotation of the Earth about itself. Any phenomenon that repeats itself can be used as a measure of time. The repetitive occurrence of seasons, the to and fro motion of a pendulum, the pulse beat, the oscillations of a spring, the oscillations of a crystal, or, as we see here, the rising and setting of the sun. The sundial is a device that has been used in the past to measure time by the sun. The gnomon casts a shadow on the base, a flat surface with markings indicating each hour. The shadow of the sun moves equal distances each hour. Grandfather clock. Our grandfather clocks consisted of oscillating pendulums. The pendulum swings to and fro, and as it swings, it turns a wheel with teeth. The turning wheel turns the second hand of the clock. Using a gear system, the hour and minute hands on the clock are driven at 60 and 3600 times slower than the second hand. Spring balance clocks. We could use a spring instead of pendulum. A coiled spring provides the to and fro movement similar to the pendulum. This makes for a good wristwatch. The wristwatches of today use quartz mechanism. Quartz is a type of crystal that looks like glass. When you apply voltage or electricity, the quartz crystal vibrates or oscillates at a very constant frequency or rate. The vibration moves the clock's hands very precisely. The best quartz clocks have kept time for a year with an error of 0.02 seconds. Light travels in straight lines. The formation of shadows is evidence of the rectilinear propagation of light. The solar eclipse is nothing but a shadow formation. The source of light is the sun. The object is the moon. The screen is the earth. When a portion of the earth is in the umbra region, it does not receive any light from the sun. This is a total solar eclipse. In the penumbra region, people can view that part of the sun from where the rays reach them. If the sun is the source and the earth the object, there are regions of umbra and penumbra behind the earth. If the moon is in the umbra region, it cannot be seen at all, and we have a total eclipse of the moon. When a pointer moves over a scale, the apparent scale reading changes depending on the position of the eye. If the observed reading differs from the correct reading because of the position of the eye, it is called a parallax error. For a correct observation, the eye should be vertically above the pointer. When a parallel beam of light falls on a concave mirror, the reflected light is said to converge at the focus of the mirror. If the mirror is large, not all rays of light converge at the focus. The locus of the points where the reflected rays meet is called a caustic curve. Whenever a ray of light travels from one medium to another, it changes its path based on its velocity. This process is called refraction. Here we see three cars moving from one terrain to another. The first car entering the sand slows down, followed by the second and then the last. The direction of the lines joining the positions of the cars simulates a wavefront. The wavefront changes when it travels from one medium to another. The source of any sound is a vibrating body. A tuning fork produces a sound because of its vibrating prongs. In a guitar, the vibration of strings with different tension and lengths produces different sounds. The buzz of a bee is due to its rapidly flapping wings. The wings vibrate close to 90 times a second. The visual shows its movement in slow motion. Sound from a vibrating body reaches our ear as a wave. What is a wave? Look at the successive groups of spectators in a stadium moving up and down. The movement of each group lags slightly behind the previous group. Group members stay in their respective positions, although the disturbance appears to be traveling along in space. This is an example of a wave. The ear can be divided into three main parts: the outer, middle, and inner ear. Sound waves are fed into the auditory canal and fall on a thin membrane called the eardrum. The eardrum starts to vibrate as a result. This mechanical model depicts the travel of sound waves through the ear. The ear is an organ in which sound travels through the air, outer ear, liquid, inner ear, and solid, middle ear. Here the three bones act as a lever system to transmit the energy onto the oval window. To show that the velocity of sound differs in solid, liquid, and gas, dominoes are arranged in 3 rows with unequal spacing. The first row represents the situation in a gas, the second in a liquid, and the third in a solid. A current-carrying coil behaves like a very short magnet. An elongated coil with closely wound turns behaves like a bar magnet and is called a solenoid, since every turn of the solenoid has magnetic lines of force around it. At every point, there is a resultant magnetic field as shown here. How can you make out which end of the magnet is north and which end south? The visual shows a conductor and a magnetic field. When a current passes through the wire, it experiences a force whereby it loses contact with mercury. This stops the current flowing through the wire. When the current stops, the wire does not experience a force, so it goes back to its original position to make contact with mercury and complete the circuit. As a result, the wire undergoes repeated kicks. The galvanometer is a current-detecting instrument. Here we see an application of the process shown in the kicking wire experiment. It consists of a copper coil wound on a light aluminum frame, pivoted in such a manner that the coil rotates in a radial magnetic field provided by 2 curved magnets. When a current passes through the coil, it experiences a deflecting torque. The deflection of the coil is proportional to the current through the coil. A pointer attached to the frame moves over a scale which has been calibrated by first passing known currents. Whenever the magnetic flux linked with an electric circuit changes, an EMF, electromagnetic force, is induced. This is Faraday's first law of electromagnetic induction. The induced EMF produces a current if the circuit is complete. The transformer is based on electromagnetic induction. It consists of a laminated soft iron core, a primary coil, and a secondary coil. An alternating voltage is connected to the primary coil. This causes the flux in the primary to change constantly. These flux lines also pass through the secondary and hence induce an alternating electromotive force. Through a transformer, alternating voltages can be stepped up or down. Geissler, in the 19th century, invented a vacuum pump. With this pump, he could produce discharges of electricity in evacuated tubes of varying shape, called Geissler tubes. When air is pumped out of the tube, the electrodes in the tube are connected by one or more violet streamers at around 2700 pascals. Continued decrease in pressure to around 700 pascals causes the pink glow to concentrate around the anode and a blue glow to concentrate around the cathode. The space between the glows is dark and called Faraday's dark space. Further decrease in pressure, 10 pascals, results in the pink region to be split into striations. Finally, at around 1 to 2 pascals, the dark space expands until the entire tube is dark except for a faint green or violet glow around the anode. The sides of the tube fluoresce, usually green. The dark region is now called Crookes dark space. Cathode rays are the glow in the gas, and as J.J. Thomson concluded, quote, are nothing but streams of negatively charged particles, unquote. He called these particles electrons. There must be positive charge within the atom, called protons, which balance the negative electrons to create electrically neutral atoms. Here we see an experiment where the beryllium is bombarded with alpha particles emitted from polonium. It gives off a penetrating, electrically neutral radiation. When these radiations are passed through paraffin, rich in hydrogen atoms, the protons emitted are detected by an ionization chamber. This radiation consists of particles with almost the same mass as a proton. These are called neutrons. All atoms consist of electrons, protons, and neutrons. Here is the principle behind the working of a cloud chamber in which particles emitted from radioactive substances can be detected. A charged particle entering a chamber containing saturated vapor produces ions. The temperature and the pressure of the saturated vapor decrease by moving the piston. The vapor condenses on the ions and forms droplets, thereby creating streaks of cloud. Different types of particles leave different tracks. Relatively heavy alpha particles produce straight, dense tracks. Light beta particles leave wispy, irregular tracks. Nuclear fission is a process in which the nucleus of an atom splits into two or more smaller nuclei. It is used to produce energy for nuclear power and in nuclear weapons. Nuclear fusion is the process which gives stars, the sun, their enormous energy, as two nuclei join together to form a heavier nucleus, releasing a large amount of energy. A nuclear reactor uses the fission of uranium in a chain reaction to generate a lot of heat. The generated heat is used to convert water to steam, which in turn runs the turbines of a generator to produce electricity. The motor is a device that provides mechanical energy when electrical energy and magnetic field are supplied. A simple DC motor consists of a rectangular wire of many turns wound on a frame. The frame is mounted on an axle between two magnetic poles. Current is passed through the coil via two brushes, which are pushed against the split ring commutator attached to the coil. The commutator ensures that the direction of current in the coil reverses every half cycle and the coil rotates in one direction. In a telephone handset, there is a microphone and a receiver. A telephone receiver makes use of electromagnetic induction. Coils are wound in opposite directions on two south poles of a magnet. Current going around one pole in the clockwise direction is reversed in the other pole, making one pole stronger. The armature tilts toward the stronger pole. The variable input current causes fluctuations, which are passed on to a diaphragm, reproducing the sound. The carbon microphone consists of two metal plates separated by carbon granules. When sound waves strike the outer plate, the pressure on the carbon granules changes, altering the electrical resistance between the plates. A direct current is applied between the plates, and any change in resistance results in a change in current. The sound signal is converted to an electrical signal.